A recent survey asked to rate your interest, X, in the environment. 0 for no interest, 1 for curious, 2 for passionate. Verify the table below forms a discrete probability distribution. Find the mean and the standard deviation. So, before we talk about probability distribution, we just worked on an example where the variables were discrete, meaning that the outcomes could be counted. So the interest in the environment, 0, 1, or 2, is certainly a variable that can be counted. So this is in fact discrete. Now probability distributions must satisfy two criteria. So first, we have to know that the probability of x, in other words, p of x, is how it's written, has to be less than or equal to 1 and greater than or equal to 0 for every outcome x. And this is true, and we can just visually verify it. The probability of 0 is 0.02. Probability of 1 is 0.48. The probability of 2 is 0.50. So every one of the outcomes has a percent, essentially, between 0 and 100%. Secondly, if we add up all the probabilities, they should be equal to 1, as in 100%. And this is true also. We can verify this by just taking all the probabilities and totaling them. So 0.02 and 0.48 is 0.50. If we add in the other 0.50 for the people that were passionate about the environment, we get 1.00, which adds up to 1. So we do have a discrete probability distribution. Now we're going to move on to the mean and the standard deviation. The mean, mu, is a little bit different when we have probability distributions. See, all the outcomes here are not equally likely. There's the people that were passionate, for example, about the environment was 50%, which is different from the people that had no interest, which was 0.02. So we can't use the formula where we just add everything up and divide by 3. It does not work. For probability distributions, and this is important, we use the formula sum xp of x. So what we have to do is make a column where all of our x's are listed, 0, 1, and 2, and then we have aside it all of our p of x's, which we have as 0.02, 0.48, 0.50. Now, according to order of operations, what comes first, sum for addition or multiplication? The answer is multiplication, so we should multiply all the xp of x's first and then add. That's what this formula says. That's the new formula for mean. So what we have to do is, before we add up all of these, we have to multiply them. Make a new column, xp of x, formed by multiplying, for example, 0 times 0.02. And that's easy enough, that's 0. 1 times 0.48 is 0.48. 2 times 0.50 is, well, it's just 1.00. Now we add them, and when we sum, we get our total. The mean is 1.48. 1.48. And you can kind of see that from our probability distribution. If we were to just add these up and divide by 3, the average would be 1. But you can see that there weren't too many people that had no interest in the environment. It was kind of weighted toward the people that were either curious or passionate, and that's why our mean, our expected value as they call it sometimes, when they're talking about probability distributions, is higher. It's 1.48. Likewise, our formula for standard deviation is also different. The formula for standard deviation, and you might want a calculator for this, is standard deviation equals, it's a square root, and it's a sum, and it's x minus mean squared p of x. So, going inside here, we look and see that we have to sum, and that comes last in order of operations. You have to multiply, but first we have to square and do what's inside the parentheses. Okay, so more columns, guys. We're going to take a column now that's x, which is all the different values, 0, 1, 2, and subtract off mean. And then we're going to square it, and then we're going to multiply by p of x. So let's see what we get. So 0 first, minus 1.48, and that's going to be squared. So let's just write it down like that. Next, 1 minus 1.48, and square that. Next, what's the next value? X is 2. So take 2 minus 1.48 squared. Now we have to do one other thing in this formula for standard deviation, which is multiply by p of x. So why don't we tack that on right here and do this all at once? So p of x, geez, what's that? Well, that's just the probability that's corresponding to every x value. For example, remember x was 0? What's the p of x there? 0.02. So we'll multiply that whole thing by a 0.02. When the x was 1, what was the p of x? It was 0.48. When the x was 2, the p of x was 0.50. And so we get that. Let's multiply all of these out and then add them, put it under the square root, and we have our answer. So I'm going to jump to my calculator here, and you should too. And first, I'm going to take 0 minus 1.48, and you might want parentheses on your calculators here, and multiply it by itself, or use the power 2 button. When I get my answer, multiply by 0.02. And I come up with 0.0438. And I'm going to use 4 decimal places right here. Next, 1 minus 1.48 squared. And that's going to be multiplied by 0.48 when I'm done. And you should confirm this on your calculator, that to 4 decimal places, you get 0.1106 if I approximate. And finally, I'm going to take 2 minus 1.48, and I'm going to multiply that by 0.50. And when I do, I get 0.1352. You might say, well, why are we going to 4 decimal places? And the reason why is because we're going to end up adding all of these and taking a square root. So I don't want to round too early and then round again when I do my square root. So if I add up all of these and I sum these, I get, and you should confirm this, .0438, 0.1106, 0.1352, adds up to 0.2896 approximately. Finally, we put that under the square root, and then I can round my final answer to 2 decimal places, and I get approximately 0.54.